Okay, welcome everyone. I'm here with Hiram Chirino, and we are doing a re-recording of the session that we gave at Summit titled Red Hat Integration Platform as a Service, Integration Made Easy. So just as a bit of background, you probably know us both very well, but my name is Keith Bablow, so you recognize my voice during the recording. I'm the product manager for Fuse. I've been at Red Hat for about a little over 8 years. Spent most of my time at Red Hat as a core developer within the JBoss engineering team. But about a couple years back, I moved into product management, and I've been overseeing various aspects of Fuse. Hiram, do you want to go ahead and introduce yourself?
Hey, I'm Hiram Chirino. I'm the Fuse platform architect. I've been a long time open source developer, worked on ActiveMQ and Camel for many years, and just focused on all things integration and Fuse.
All right, so let's get started. So we really want to drive a lot of this from a live demo and really show you what Fuse and iPaaS have to offer here. But just to set the stage a little bit, when we talk about iPaaS, what really are we talking about here? And I think it makes sense to break it down to three fundamental categories. The first is that we're taking integration and making it available to new classes of users. So we want to make integration technology today, whether you're doing microservices development, traditional ESB style development, you really, from a technical level, want to package up your integration logic and deploy it where you need it. But we're starting to see more and more that in the traditional integration developer was kind of a hardcore developer, really understood the integration, enterprise integration space. And we're seeing a new class of integrator emerge here, where it's people that understand business processes and understand business data, maybe understand some basics around integration, but they're certainly not hardcore developers. And these folks are adopting SaaS software and getting more and more involved with verticalized IT applications, and they want to perform integration on their own. And so one of the chief audiences we're trying to address here is what's commonly referred to as a citizen integrator. So it's this user that's not extremely technical, not a developer, but still wants to solve integration problems. The second thing we're trying to do with iPaaS here is provide a presentation of our integration technology that's 100% cloud-based. So that means the tool chain for creating integrations, creating your flows that will connect various systems and do your data mapping and everything else you do that's involved with integration is completely hosted in the cloud. So nothing to install locally. It's all web-based interface. We also want the ability, once we've created that integration, to go ahead and deploy it and run that integration in the cloud as well. So 100% cloud-based toolchain and runtime for integration. And then the third aspect is that the types of integration we're talking about here are really kind of the meat and potatoes of the integration world, right? So we're talking about routing, connectivity to lots of systems, and data transformation. And these are all technologies that, if we look at the Fuse stack, we look at Camel and CXF, are fantastic technologies to address this need. So let's put this, that was kind of a bit of background, theoretical background. Let's put this into a concrete example. So imagine that your company has run a corporate event, right? And what you'd like to do is, your company's very active on Twitter. And what you'd like to do is, after this corporate event has concluded, you'd like to monitor Twitter and see what kind of reaction you're getting. And for every user that mentions your company in your event, what you'd like to do is upload the contact details for that user so that you can actually follow up with that user and understand, like, if they'd like to learn more about your company, and basically create a sales lead flow. So very, very, easy to understand, practical use case here. And the question is, do you really need to now, like, if you've had this idea and you work at a company, do you need to go contact a developer to go write a bunch of code and deploy it somewhere and go through an acquisition process of finding hardware and provisioning it? Or would you like to use a tool like iPaaS to go ahead and create and provision this environment completely in the cloud? So let's actually follow that latter scenario and look at a demo where we could use a 100% cloud-based toolchain and runtime for connecting Twitter and Salesforce. Hiram, do you want to show us how it's done?
So I'm going to be demoing to you guys how to create an integration with the iPaaS. The first step is once you logged into Syndesus, you click on this integrations tab where you can see all your existing integrations. Then you're going to be creating a new integrations by clicking this button, create integration. The first step in an integration is determining where's the source of this integrations data coming from. And in this example, I'm going to be getting tweets from my Twitter account, so I can filter down all my connections by with this filter here. I'm going to pick Hiram's Twitter, and then the next step is selecting which action off of Twitter it is that you're interested in getting information from. So I'm going to select this mention one because I want to know when people are mentioning me. I'm going to pick that. And then the next step is choosing to which system is it that you want to send this data to. And I'm going to be sending it to Keith's Salesforce because I think he wants to spam anybody who mentions me. All right. So I'm going to create, and then the next step on this one too is picking an action that you want to take on the Salesforce connection. And what we want to do is I want to either create or update an existing contact based on the Twitter screen name of who created that mention. So this field is basically just the field name of the Salesforce custom object that we're using, and that's what's going to be determining if we create or update an existing contact. So I'm going to hit next, and basically that's the basics of creating an integration. But like in all integrations, there's typically the data from the source system doesn't exactly map to what the target system wants. So we're going to want to add a step here by clicking this button, add a step, and picking this data mapper step. Data mapping lets us convert data from the source system to the format that is expected by the target system. And here we see on the left the data that comes from the Twitter system, and on the right we'll see the contact object that we want to fill out in the Salesforce system. The first thing we want to map is we want to go into the user nested field here and pick the user name, so boom, right there, and we're going to want to map it to the first name field, right? Now name is first name and last name in Twitter, so we're going to need to split this field into first and last name. So we're going to switch the action for map to be separate, and we're going to add a target, right? So the first index will be first name, and then we're going to target the last name field, and it's going to be the second part of the split value. Okay. The next thing we want to do is we want to look for the screen name, the user screen name, and we're going to map it over here. Let me just do searches so that way it's easier. And we're going to map it to that Twitter screen name field, custom field in Salesforce. So that mapping's done. And then lastly, I think I want to take the text from Twitter, the text, and I'm going to put it into the description field on the Salesforce object. And we're done doing our mappings of the interesting fields that we want to put into the contact object. And so I'm going to click next. And that's it. And that's all there is to the guts of creating this integration of taking data from Twitter to Salesforce and running it through a simple mapping. Now let me save this integration. Let's give it an integration name. We're going to go Twitter to Salesforce mentions maybe. And we don't really need a description, so I'll fill one in and I'll go publish. And now this integration is currently being built and deployed into OpenShift. Now that takes a little bit of time, so what we've done is we've actually got the same kind of integration running already. As you can see here, it goes from Twitter mention to Salesforce create update contact. It has the same data mappings as we've done before, right? So let's just take a peek at what it does. Here I'm going to switch over to Salesforce, and these are our current contacts, and all we need is somebody to send a tweet to Hiram Chirino at Twitter and mention me, and it should come in. So Keith, you want to try doing that?
Sure thing, Hiram. Okay, let me create a quick text here that says, great event, looking forward to the next one. And that has been tweeted.
Okay, so here pretty soon we should see that contact appear in this contact. Oh, look right there, recent contacts. Keith is now on the list. Sweet. He's got, look at the description. Great event, looking forward to the next one. So integration worked.
Wow, that was a great demo, Hiram. And as I mentioned earlier, what we want to do is spend most of this presentation just dissecting those bits and pieces that we just saw and going a little bit deeper to help you understand exactly what functionality iPaaS offers. But first, I just want to talk about one thing, which is that where does this fit when we talk about iPaaS? Where does this fit in the Fuse product roadmap? When we look forward to Fuse 7.0, there are going to be three presentations of Fuse. The first is Fuse Standalone, which is probably the version of Fuse that most people are familiar with and comfortable with today, which is picking up Fuse, Camel, CXF, Carafe, and running that on a JVM. In this case, standalone means that it's just running in a single JVM. So it's not clustered or provisioned by Fuse. It's actually just running single JVM on a variety of operating systems. In order to get clustering and provisioning capabilities in Fuse 7, that's where Fuse Integration Services for OpenShift comes in. So Fuse Integration Services for OpenShift allows you to take the same core technologies that are used in Fuse Standalone and actually deploy that onto OpenShift. And then finally, Fuse iPaaS will be the third distribution of Fuse. And iPaaS is what this entire presentation is going to be about, so I'm not going to go into any more detail then, other than just to recognize that in Fuse 7, we'll have standalone, FIS or Fuse Integration Services, and iPaaS. Now, one important detail here is that all of these distributions are related. It's a single product offering, and it gives you the power to use integration in the way that you need to do it. If you need to do a little bit of integration in the corner of your enterprise and run it on a JVM, then you can use Fuse Standalone to do that. If you want to do, big scale out clustered integration, or maybe some greenfield microservices development on the world's most advanced container orchestration platform, then you would use Fuse Integration Services on OpenShift. If you have a class of users that are more of the citizen integrator style, who are not hardcore technologists but want to do integration, then you would use iPaaS. But these are all part of a single product offering. All these technologies move forward together in Fuse. They're all version aligned. How that looks, just focusing on the iPaaS bit to kind of tie that together, is iPaaS as within Fuse will all be based on OpenShift Online. So all of iPaaS is distributed as containers that run on OpenShift Online. Inside your OpenShift Online account, there's a couple of important pieces. First is the iPaaS infrastructure, all the important bits that sit behind that UI that Hiram just showed to make the iPaaS work. And then, of course, there's your application. Now, the cool thing is that when you're creating through the iPaaS UI, you're not really getting into the details of how the project is assembled and packaged. But underneath the covers, every iPaaS application is actually a Fuse Integration Services app. That means that you can create your application through the iPaaS UI and then deploy it anywhere where OpenShift runs, because Fuse Integration Services runs wherever OpenShift runs. But it also means that you can use the iPaaS UI to create that application and then just run it directly on OpenShift Online. And then, of course, there's the iPaaS UI, which Hiram just showed, and we'll get into a lot more detail about through the rest of this talk. All right, Hiram, do you want to take over and take us a bit deeper?
All right. So the first thing I want to cover more in depth about the iPaaS is the concept. It's basically some terminology we use in the iPaaS. The most important one being connectors. iPaaS connectors are the foundation of our iPaaS. They allow the iPaaS to connect from brownfield systems all the way to new SaaS applications. They're implemented with Apache Camel components, and Apache Camel supports connecting to over 150 different systems and technologies. This catalog of connectors is extensible, and not only will you be able to enhance existing connectors, but also add custom connectors to this list to suit your needs. The next concept is that connectors basically define additional metadata in addition to what's provided by Camel components. This extra metadata allows the iPaaS to give users a simple and intuitive user experience, while Camel components give developers a tremendous amount of functionality in using URI-based configuration syntax. We needed to simplify this down for citizen users so they could use more form-driven user interfaces to configure connecting to remote systems. These connectors define those general options that establish those connectors to our remote systems, like host names, usernames, passwords, secrets, access tokens, and things of the such. They also define what are the valid operations that you can take against those systems. Can you pull for files? Can you, like in the Twitter case, look at recent mentions? And those actions also contain metadata about the way the shape of the data that's returned from those operations. Right? It's like they define the schema of the data that they will be the user will be interacting with. Okay, so the next important part is iPaaS connections. These define how to connect to those specific instances of the systems. Like I said, the connectors say like what data you need to collect to create a connection, but when you go into in the iPaaS, you can actually create multiple connections for a single connector. You could connect to different Twitter accounts, for example, and each would have its own connection. They're typically used to hold information like credentials, but they could also have some um, common configuration for the connection to simplify its use when it's used in integrations. This allows you to create connections in a single place and then use those connections across multiple integrations. So you only have to define how to connect to Hiram's Twitter account once, and then you can use that Twitter connection in multiple integrations, like to search for Twitter mentions. You can do things like search for specific Twitter text, text searches of anybody making any mentions of some explicit text. And also, as you create connections, you can also validate that your connection properties are valid, as shown in this next screen. Sometimes with these big tokens, access tokens and secrets, it's easy to get something wrong, cut and paste something incorrectly. And when that's the case, you'll get a message like this saying that, like for example, if you put something wrong, Twitter would say cannot authenticate you if it was invalid. But hopefully, if everything's put in properly, you'll get proper validation. Twitter will confirm that, yeah, you could connect to this connection properly, and everything is good. So once you got those connections going, the next part is creating integrations. We saw how Keith showed us how easy. Oh, not Keith, I did it myself. Okay, so the next part, let me give it a gap. There we go. So the next important thing to look at is creating is integrations. I showed you guys how to create those integrations earlier. It was really easy, but we kind of went through it very quickly. So we'll slow it down a bit here and actually go into detail exactly everything that happened while we created that integration. First off, let's look at exactly what an integration is, right? The point of an iPaaS integration is to connect data from one external system to another one. The integration can add additional processing steps in between, connecting the source system and the target system as as so that you can modify that data as it flows from the starting connection to the final one. Those processing steps allow to use simple integration patterns to modify, transform, filter, or enrich the data to get into the shape that the target system wants it in. Finally, the iPaaS handles taking this integration created by Citizen Integrator and creates a developer-friendly FIS project that gets deployed to OpenShift. Starting ending connections. If you recall, the first step I took was to choose a starting connection and the action to get that data from the source system. I picked the action and then I selected the ending connection and its action. Actions are select common high-level activities for components and connections. If an action requires additional configuration properties, then a form can be easily understood by the citizen developer or integrator is shown to collect that additional information. Notice that some actions may not need any additional configuration, like the Twitter mention action that we used. You just picked it and you moved on to the next step. There was no additional information needed. Actions use the metadata defined in connections to refine the remaining set of parameters to those that only make sense for the specific activity that's being done. Sensible defaults are provided for most configuration properties that are presented to the user. Steps. Steps are those things that let you do that massaging of data. They're high-level patterns that are useful for non-developers. No development is required to do these. The one that we demonstrated was the data mapper, which will be a common step that is added between the integration connections. But you also have other steps available for doing additional actions like filtering, conditional processing, splitting of data received from source systems. So now that we looked at integrations a little bit in detail, let's take a look at this from the perspective of a developer. Um, you should know that we're not leaving the hardcore Camel developers behind. Um, the developers might be thinking, hey, this doesn't look anything like Camel. How can I apply my Camel knowledge to the iPaaS? And just so you know, you guys can contribute to existing iPaaS projects just fine. Because an iPaaS integration is just basically creates a FIS project, a Spring Boot based FIS project, which uses Camel under the covers, and this thing gets deployed to OpenShift. These projects should be easy for existing Camel developers to understand, and they should be able to really see how it is that the iPaaS is creating these integrations. One of the unique files that the iPaaS brings to a Camel project is this function.yml file. It's a new Camel DSL that uses a YAML based definition of Camel routes, but it just uses the iPaaS basically provides a Camel route builder that turns this function YAML at runtime into a set of Camel processing routes. But developers can still add their own custom routes into the iPaaS. They can use Java or XML-based DSLs to add additional routes, since this is just a plain Spring projects. And they can do this to add more complex routes that maybe the citizen integrator would have a hard time creating integrations for. Here's another file that's probably pretty common to all Camel projects. It's a Maven POM file. It's just like all FIS projects. This file defines how to build the integration. Um, the one interesting thing about the Fizz projects is that it uses Spring Boot as the way to package and inside and deploy into OpenShift. So here we see that this file is defining a Spring Boot Maven plugin to basically package up our application as a Spring Boot bootable Uberjar, right? The data mapper. Let's take a look into the data mapper and what makes it tick. Um, it's one of the most complex and most useful steps in the iPaaS for integrating from source to target systems. When we first looked into what we were going to use for data mapper, we kind of scoured for all the open source mapping, data mapping solutions that were available to us, and we really couldn't find one that kind of ticked all the requirements. It needed to be open source. It needed to have good XML, JSON, and Java object mapping support. It had to have a modern UI that we can integrate into the iPaaS um, screens. And none really kind of fit the bill. So we helped start up a project called Atlas Map, which is one of its goals is to be independently usable outside of the iPaaS. And it supports all those common data formats that we need in iPaaS. Um, One of the things that we tracked in that connector metadata in the iPaaS is something called the data shape. It's the shape of the data that's either going into an action or coming out of an action. And these data shapes can either have a schema defined to describe the data shape. So it can be an XML schema or a JSON schema, or basically use a Java object definition as the schema for the data. Or it can also have an example XML or JSON document as an instance document that's used to kind of dynamically figure out the shape of the documents. All this schemas and data shapes and all this, it's used so that the users of the iPaaS don't need to worry about telling the iPaaS what those data shapes are. The connectors and connections basically keep track of all that under the covers and feed it into the data mappers so that the data mapper can do its job of presenting to the user an easy to pick from shape to map from and to. So let's take a quick peek at the Atlas Map data mapper architecture here. It's a really flexible system. There's a core transformation engine which has pluggable input and output handlers, right? The input handlers are for each data format it supports. It also has output handlers for those data formats. It also has plugins that allow you to do additional um, processing on the data like transformations. And this whole core mapping engine gets wrapped up in a camel component. So the way we use the mapping engine is via a standard camel component. All right, so some more detailed features for the data mapper is it supports mapping for multiple source documents. That means that we can perform multiple actions in an integration and then use the output from those actions and map those into a single target document that then is used as the input for another action. So we can kind of collect data across different actions in the integration, aggregate that together, and use that as a next step. It also has auto type conversions, so you don't have to worry about converting integers into strings and things like that. It automatically takes care of that. It supports separating fields into multiple target fields. It supports combining multiple input fields into a single target field. It can do lookups of values, right? You can use a source field across a lookup table to get the resulting value that you want into the target. Of course, you can just use constants that you configure into the target fields. and it has multiple field functions to do things like case manipulations, substrings, joins, things like that, right? Um, so next part up is the runtime. Um, when the iPaaS publishes an integration, it's generally going to do something along the lines that it looks like in this slide. The first thing we do is we push the project source code up to GitHub. Then we configure OpenShift with deployment configs, and which basically will ask OpenShift to check out that source project, build it, and then deploy it into OpenShift. So what's that look like? Firstly, when the iPaaS creates a project, it's going to create one in GitHub, like the one you're seeing here. If the project doesn't exist, it's going to create it. It'll create webhook notifications, or set up webhook notifications on this GitHub project, so that when updates happen to it, it notifies OpenShift so they can trigger off a rebuild of the project. The next part is here, we got a build configuration that we create. Um, and this basically kind of controls how we do the build. We use an S2I builder to take the source code and build it just like the Fizz S2I works. We use the same builder as Fizz, and the result of running this build is a new container image that we can use to run this integration. Another important thing that the iPaaS will generate is a set of secrets for the integration, right? We'll create uh, a secret and basically mount it as an application properties file, right? Um, if you're not aware, OpenShift secrets is basically the standard mechanism used to hold sensitive information such as passwords on OpenShift. The connector's metadata let us know which configuration fields contain sensitive information, and the iPaaS will only store those values that are considered sensitive in this secrets file. All other non-sensitive configuration gets stored inside your Git project. Um, and once again, this application properties secret file is actually just mounted into your running container, so it's all transparent to the user or to the deployer. Um, one of the last things we do is basically create a deployment configuration, which basically defines the container's environment. It configures what's the image name that we're going to be running. It basically defines, hey, which are those secret files we're going to be mounting, where do we mount them. It also is used to control the rolling deployment of integrations, and it watches your containers and running pods, so that way if they have failures, they automatically get restarted. And at the end of the day, once your integration is actually running and active, you end up with one pod running in your OpenShift namespace. Our pods are configured with things called readiness and health checks, and they allow us to know when the pod is healthy or not healthy and we need to take it offline or restart it. We just plug into the standard Spring Boot actuator health checks, which FIS recommends people use. And that's it. And that's how the integrations are run. Finally, for management and monitoring, developers could drill into our iPaaS integrations just like any other FIS deployment. They expose themselves via OpenShift detailed monitoring, right? In OpenShift, when a Fizz pod is running in the console, there's a click to get into to look in details at the Java console, and you'll see things like camel routes, basically JVM metrics, and kind of be able to get detailed information about the JVM. If you also want to do like more in-depth debugging of what's going on with the integration, OpenShift also provides a standardized way to get to logging. Um, Basically, they all go via the standard OpenShift logging facilities, which you can access either via the OC command on your command line or via the OpenShift console's logs tab, as seen in this picture. Since it's all managed by OpenShift, there's less operational management that operators have to worry about. So I'm going to hand over the next hybrid integration part over to Keith.
Thanks, Hiram. So talking about hybrid integration, what we're really talking about here is how the organizational model for integration is maturing and evolving. If we look here at the left of this picture, we can see that what's been the more traditional model for integration development in most enterprises, which has been there's a core team of integration experts that are developers that manage everything, that manage the entire integration runtime. Any departments within a given company that want to do integration go to this team, and that team, they submit some requirements, and then there's a cycle for implementing those requirements, and it gets deployed, and you kind of rinse, wash, and repeat. And what we're seeing is that model is still very valid. You still want this core competency group of people that are experts in technology and in integration, but we're starting to see that evolve a bit so that that group doesn't have to be a bottleneck anymore and control all aspects of integration. And there's two ways that that's changing. One is with the citizen integrator that we talked about. These are users that are rapidly adopting SaaS and cloud-based software, whether that's Salesforce or ServiceNow or Workday or whatever. And these users are actively using these SaaS applications, and they're looking for integration tools that are also cloud-based to handle integration between these SaaS systems. Likewise, we see on the right here that we're starting to see, with the microservices movement, we're starting to see functional breakdowns where companies are organizing around distinct pieces of functionality that are independently deliverable by smaller teams. So the core integration center doesn't really scale to match this because that's a single unit. So what the people are doing is they're taking individuals and placing them on specific teams and using that to drive development. So really, this isn't a right or wrong thing. It's just a reflection of the fact that the kind of development model around integration is turning into more of a hybrid model of these various styles. So when we look at that from an iPaaS standpoint, we actually want to encourage both two types of development. One is we see on the right here the citizen user using the iPaaS UI with a completely cloud-based tool chain to go ahead and create integration apps, right? That user, when they go ahead and create that integration app, it's backed in a Git repository. So that iPaaS app lives in a Git repository, which means that any other developer that comes along can go and clone that Git repository and work on the same project. So a common scenario here might be that you have some very basic integration logic connecting, let's say, an internal API and Salesforce. But as part of this integration logic, you want to do a table lookup on a backend system that involves a lot of low-level coding, and you certainly don't want to expose your citizen user to that. So the citizen user can create the high-level integration, commit that with the iPaaS UI, and then the developer can come in and add additional route to that application that does all the messy underlying integration work. And then that application, once that code is committed back into the same Git repository, that application can be deployed anywhere you deploy an iPaaS app. And the model we're trying to encourage here is this collaboration between the citizen integrator and the expert developer to create apps together. Sometimes you only need an expert developer. Other times you only need a citizen integrator. But there's lots of cases where both of these users can help each other out and produce better applications. So that's sort of where we see hybrid development going in the world of iPaaS. And there's also the question of hybrid deployment. So in this scenario, we talk about companies, all companies have a cloud strategy, right, of when they'll be in the cloud. And for some companies, that's 2.5 months. And for other companies, that might be 25 years. It could be an insanely long window to get out there. And there's lots of reasons for that. There's the pace of change within an individual company. There's regulatory requirements. There's security. There's many factors there. But the important thing is that most companies are on this kind of spectrum and that they're looking to adopt cloud-based technologies over time. So it's never going to be a light switch on off type of scenario. You're starting to incrementally roll out more and more into cloud. The great thing is when we talk about iPaaS, it has the flexibility of being completely cloud-based in terms of the toolchain and the runtime, but it can also be used to create applications that are deployed on premises. So if we look at the left here, we see a full cloud option that's all based on OpenShift Online. You can also, and that would be multi-tenant, you have a single tenant presentation of that, an OpenShift dedicated, so your company works within a specific area of a Red Hat managed cloud that's just your company, and you can create and deploy iPaaS applications there. And then, of course, you can actually use either on premises or in the cloud the toolchain to create an iPaaS app, and then to deploy that on OpenShift Container Platform, either on premises in your own data center or on a third-party cloud provider like Azure, EC2, or Google Cloud Platform. We'll talk briefly here about the product roadmap. I encourage you that we have another summit talk that was the integration roadmap that Jack Britton and I gave, and that provides a lot more detail on the product roadmap. But just in terms of schedule and when you can expect some great stuff coming out here around iPaaS and Fuse 7, we are planning a public preview release of iPaaS in September of this year. That will be built around a core set of scenarios that we want users to exercise and give us feedback on, and really allow you to kick the tires and experience all we think iPaaS has to offer. Once we release that preview release, we're going to look to do regular refreshes of that technical preview over time as we build out to GA. As I mentioned, iPaaS is a part of Fuse 7 overall, and so what we're doing is we're going to have incremental releases of that all the way up until Fuse 7 GA, which is currently targeted for Q1 of 2018. So look for more in terms of announcements and details around that iPaaS preview release in the next couple months. And that's it. So thanks very much for joining. And if you have any questions, please feel free to reach out to Hiram or myself for questions.